All right, ladies and gentlemen. Here we go. This is actually our last section of this, and I know there's a glare there. It is exponents, power to a power. So what does that mean? Well, we've got a lot of exponents here. Quick recap of what we've done. X to the third times x to the fifth. When we got to remember what your base problem is. This is a multiplication problem, so my shortcut is to add. If I have x to the third over x to the fifth, that's a division problem, so my shortcut is to subtract. So I would subtract and get 2, and then of course it's 2 on the bottom. Okay, so these are the rules that we've talked about so far, and then that brings in the negative exponent rule, where we have to do the reciprocal. Now today's rule looks like this. When you have a power raised to another power, okay? So we call it power to a power. When you have a power to a power, you multiply the powers. Power to a power, you multiply the powers, okay? So this is a to the m times n. You multiply the two exponents together. So simply put, if I have x to the third to the fifth, that would be x to the 15th power. Power to a power, you multiply the powers. So, if there's more than one exponent, or more than one variable inside, they all are being taken to the 7th power. See? So I need to multiply all the exponents times 7. So this would be x to the 14th, y to the 28th. Power to a power, you multiply the powers. All right? Now, where this gets confusing, okay, you need to remember that what we're doing here, all right, so let's break this down a little bit, is I'm taking each piece. This has 3 pieces, 3 factors, 3 parts. Talked about this last week. Remember, the coefficient and the variable, those are 2 separate things. This 3 is only on this x. This y has its own exponent. Got that invisible 1 here. The 3 is separate from the x. So this needs to go to all 3 pieces. I need 3 to the third, x to the third, y to the first, to the third. Everything gets taken to the 3rd power. That's just an exponent. Calculator's going to come in real handy, as these numbers might get big on you. But I have 3 to the 3rd power, that's 27. This is my exponent rule. Power to a power, I multiply the powers. So don't get confused about coefficients and exponents. We talked about this last week. They're very different things, follow very different rules. And then here, 3 times 1 is 3. So don't get confused between doing 3 to the 3rd power and x cubed to the 3rd power. This is a coefficient. Use a calculator. This is power to a power rule. Just multiply the exponents together. So, to do this quickly without the extra writing, this is a coefficient. 7 squared is 49. Then I say power to a power, multiply the powers. Power to a power, multiply the powers. All right? Now, to make things even a little bit more fun, if there's a negative out front, all right, so I gotta remember, -5 to the 3rd power. You are gonna want a calculator here. You're gonna wanna go off to the side and put -5 to the 3rd power. Remember, parentheses are important with exponents when we're taking numbers to the power, okay? If you're putting this in a calculator, put it in parentheses so it gets it right, all right? If you're trying to use your phone or whatever and it doesn't do exponents, get a real calculator. This is -125. So when I take negative 5 to the third power, it's negative 125. Then power to a power, I multiply the powers. All right? Next, again, you're going to want a calculator here. Negative 2 to the fourth power. Negative 2 to the fourth power, that's going to come out to positive 16. Okay, get a calculator so you get those signs right. That's positive 16, power to a power, 88. Remember your invisible 1, b to the fourth power. All right, there you go with your exponent rules. Ask questions. Good luck.